In this slide, we're focusing on understanding and implementing the SLSA framework. It has become apparent, especially after recent high-profile attacks like those on SolarWinds and Kodakov, that vulnerabilities within the software supply chain are being exploited by attackers. These bad actors are now targeting build processes and dependencies as entry points for injecting malicious code. This presentation is designed to educate both developers and the information security team about the SLSA framework, which is backed by Google and the Linux Foundation. We'll explore how this framework can help protect the integrity of software artifacts, ensuring a more robust and secure supply chain. In this section, we'll explore the main objectives of the presentation. Our first goal is to understand the SLSA framework. It's important to grasp its levels, requirements, and benefits to effectively leverage its guidelines. Secondly, we aim to discuss the implementation of SLSA practices. This involves learning how to integrate SLSA controls into your current development and build processes efficiently. Lastly, we focus on enhancing supply chain security, which is essential in making it more challenging for attackers to introduce malicious code into the system. These objectives are designed to provide you with a comprehensive understanding and practical approach to securing your software supply chain. The slide addresses the question, what is the SLSA framework? At its core, the Supply Chain Levels for Software Artifacts, or SLSA, is designed as a security framework. It sets out a checklist of standards and controls specifically aimed at preventing tampering and enhancing integrity. This framework serves a pivotal role in ensuring that the packages and infrastructure utilized within software development are secure. The purpose of SLSA is to protect software supply chains by guaranteeing that software artifacts possess verifiable integrity and a clear provenance. Additionally, it provides a structured approach for organizations seeking to reach higher levels of security maturity. In essence, SLSA offers a roadmap for maintaining the trust and authenticity of software as it traverses through the supply chain. SLSA matters because it addresses significant supply chain risks by mitigating threats from compromised build environments and dependencies. This ensures that software consumers can trust the origin and integrity of the code they utilize. Furthermore, it assists organizations in complying with emerging regulatory requirements for software security. Industry giants like Google and the Linux Foundation back SLSA, promoting its widespread adoption. When exploring the core elements of SLSA, it's essential to understand the facets that ensure software security and integrity. First, we have provenance showing how the artifact was built. This involves metadata that fully describes the origins of a software artifact, allowing users to see exactly how it came to be. Secondly, signed provenance generated by a hosted build platform provides a layer of security as the provenance metadata is cryptographically signed by trusted build environments. This adds a level of assurance to the information provided. Finally, hardened build platforms refer to secure and controlled environments for building software, ensuring that the build process is protected from external threats. These elements together make up the core framework necessary for maintaining the integrity and trustworthiness of software supply chains. In this slide, we're focusing on the concept of provenance in software supply chain security. Provenance refers to the metadata that outlines the origins of a software artifact, detailing the source code, dependencies, and build process involved in its creation. The importance of provenance lies in the transparency it provides, allowing stakeholders to verify that an artifact was built as intended. To implement provenance effectively, it's essential to automatically generate detailed metadata during the build process. This metadata should encompass the source code repository and commit ID, build instructions, and the specific dependencies and their versions involved. By leveraging this information, organizations can maintain integrity and trust in their software artifacts. In this section, we'll explore the concept of signed provenance generated by a hosted build platform. Cryptographic signatures are central to this process. By employing cryptographic techniques to sign provenance metadata, we can ensure its integrity. This means that the provenance cannot be altered without detection, providing a secure record of how an artifact was built. Hosted build platforms play an important role here. By utilizing centralized and controlled environments, such as Google Cloud Build, GitHub Actions, or in-house CI/CD systems, we can maintain a secure and consistent build process. These platforms help authenticate the source of the build, offering assurance that the build process remains untainted and operating as intended. The benefits of using cryptographic signing and hosted build platforms are clear. They not only authenticate the provenance but also provide confidence that the build process was secure and uncompromised, reinforcing the trustworthiness of the software artifact. On this slide, let's focus on the concept of hardened build platforms and the necessary security measures. It's essential to implement strict access controls and ensure isolation of your build systems. Regular updates and patching are needed to keep them secure. It's equally important to monitor these systems for any suspicious activities that might indicate a breach. Regarding best practices, using ephemeral build environments is key. These environments, once their job is done, are destroyed, preventing any residual data from becoming a target. Limiting network access strictly to needed services minimizes exposure to potential threats. Moreover, employing two-factor authentication and role-based access control ensures that only authorized personnel have access to these environments. The outcome of employing these measures is significant. By reducing the attack surface, the risk of attackers inserting malicious code during the build process is greatly diminished. These practices are instrumental in maintaining a secure and trustworthy build process. In this slide, we explore the different levels of supply chain levels for software artifacts, or SLSA. SLSA is a framework aimed at enhancing supply chain security. SLSA Level 1 focuses on establishing basic build integrity by using a scripted build process and generating provenance metadata. This forms a foundation for visibility within the build process. Stepping up to SLSA Level 2, the goal is tamper resistance. Here, the use of version control and hosted build services is paramount. The build service must generate authenticated provenance, which helps defend against basic threats. Moving forward to SLSA Level 3 offers extra resistance, which involves hardening the build service and requiring a two-person review of all changes. This level is about countering more sophisticated attacks. Finally, SLSA Level 4 provides the highest level of assurance. It mandates a hermetic, reproducible build process and enforces verified provenance, ensuring optimal security for the supply chain. When implementing SLSA within your organization, there are three primary steps to consider: assessment, planning, and execution. Begin with an assessment by evaluating your current build and release processes in relation to SLSA requirements. This will help you identify the current SLSA level of your artifacts. Following this, engage in planning by setting achievable goals to advance to higher SLSA levels, focusing on critical projects and areas with high risk. Finally, move to execution. This involves updating build systems to generate and authenticate provenance, hardening build platforms following best practices, and educating team members about the SLSA requirements and procedures to ensure a cohesive transition. Adopting SLSA offers a range of benefits for your organization. First, by focusing on artifact integrity, you ensure that your software artifacts remain unaltered and authentic, thereby strengthening the security of your supply chain. Enhanced trust is another significant advantage, as you provide customers and users with confidence in the software they rely on. Additionally, aligning with SLSA prepares your organization for future compliance with supply chain security regulations, making regulatory alignment a proactive step. Lastly, risk reduction is crucial, as it minimizes the potential for supply chain attacks to affect your software, contributing to overall organizational robustness. In this slide, we're focusing on Google's implementation of SLSA practices to safeguard its extensive software supply chain. Google's approach to SLSA involves several key components. They utilize Cloud Build to produce signed provenance for artifacts, which helps assure the authenticity of their software components. Furthermore, they enforce rigorous access controls and conduct thorough code reviews to maintain the integrity and security of their software development process. Additionally, Google employs reproducible builds for their critical software. This method ensures that the same source code can consistently produce identical binaries, which reduces the risk of unauthorized alterations. As a result, Google has managed to elevate the security of its supply chain, significantly lowering the occurrence of supply chain attacks. By adopting these best practices, Google's a notable example of how robust security measures can be implemented in large-scale software development environments. In this slide, we're exploring how Kubernetes has adopted SLSA principles to bolster its release process. Kubernetes generates provenance metadata for its releases, ensuring that each artifact's origin and integrity can be traced and verified. For this purpose, they utilize SigStore, a set of tools designed to sign and verify artifacts, adding an additional layer of security. Kubernetes has also fortified its build environment by enforcing strict access controls, protecting the infrastructure from unauthorized access or changes. These measures have resulted in a greater level of trust in Kubernetes releases and have established a solid framework that other open-source projects can emulate to improve their own security postures. Implementing SLSA controls comes with its own set of challenges. Firstly, the complexity of the implementation can be daunting, particularly when dealing with legacy systems. It's crucial to identify and address the critical components initially, gradually extending coverage to the rest of the architecture. Secondly, there are tooling gaps. Mature tools for generating and verifying provenance are still emerging. To tackle this, leveraging community-supported tools like SigStore can be beneficial, and actively contributing to their development ensures these tools evolve to meet growing demands. Lastly, there's the hurdle of cultural resistance. Teams might be apprehensive about altering established workflows. Overcoming this involves educating stakeholders on the significance of supply chain security and providing them with the necessary training to integrate these practices seamlessly into their daily operations. When we face challenges in implementing SLSA, adopting a structured approach can be immensely helpful. First, consider a phased implementation. By incrementally integrating SLSA levels, we can set realistic timelines and milestones which help in managing complexity, especially when dealing with legacy systems. This reduces overwhelm and ensures a smoother transition. Next, automation is key. By automating provenance generation and signing, we significantly reduce the manual effort required and ensure more consistent and secure outcomes. This addresses tooling gaps by streamlining processes and leveraging what is already available in the community. Finally, collaboration cannot be ignored. Engaging with the open source community and industry groups allows us to share findings, best practices, and tools. This not only aids our journey, but contributes to the broader ecosystem, striving for improved supply chain security. By incorporating these strategies, overcoming implementation challenges becomes much more feasible. In this slide, we focus on best practices for maintaining supply chain security, an essential aspect of software development. First, it's vital to maintain an up-to-date software bill of materials, or SBOM, which involves keeping an accurate inventory of all software components and dependencies. This practice ensures transparency and traceability throughout the supply chain. Next, ensure you use trusted sources for downloading dependencies. It's important to rely on official repositories and verify both checksums and signatures to maintain the integrity and authenticity of the software components you are using. Regular audits and continuous monitoring of your build systems are also essential. This involves keeping an eye out for anomalies and conducting periodic security assessments to identify and mitigate any potential threats. Lastly, incident response planning is crucial. It's important to have a comprehensive plan ready to address any supply chain security incidents that may arise. Being prepared helps in quickly mitigating impacts and restoring normal operations. By following these best practices, you are strengthening the security posture of your supply chain. In this slide, we're focusing on the next steps for implementing Secure Software Lifecycle Assurance, or SLSA. First, it's important to evaluate your current supply chain security posture. This means taking a thorough look at your existing processes to identify any gaps or areas that need improvement. Next, plan your approach by developing a roadmap. This roadmap should outline the steps necessary to advance towards higher SLSA levels and enhance your security measures. Finally, it's time to implement these SLSA practices into your build processes. Start integrating these practices systematically to ensure a more secure and resilient supply chain environment. By following these steps, you're setting the stage for a robust SLSA implementation. In order to successfully implement the supply chain levels for software artifacts SLSA framework, there are several key resources you can rely on. First, the SLSA official website at slsa.dev provides comprehensive guides and documentation to help you understand and apply the framework effectively. For tooling, you have options like SigStore, which assists in signing and verifying your software artifacts, enhancing the integrity of your supply chain. InToto is another valuable tool, offering a framework specifically designed for supply chain security, providing the necessary infrastructure and assurance. It's also beneficial to engage with the community. By participating in SLSA community forums and mailing lists, you can join discussions, gain insights, and share experiences with peers who are also working towards improving their supply chain security. This community support can be invaluable in navigating challenges and learning from the collective expertise. Now that we've explored the resources available for SLSA implementation, both in tooling and community support, it's time for an open floor for questions and discussion. Feel free to ask any questions, share your comments, or discuss any experiences you have had with securing your software supply chain. This is also a great opportunity to engage with your peers and gain insights from their experiences. Please don't hesitate to contribute. As we conclude this section, let's recap the fundamental points we've covered. We emphasized the significance of securing the software supply chain. This comprehensive approach not only mitigates risks, but also fortifies trust in the software we develop and deploy. We explored the SLSA framework, highlighting its key components and the benefits it offers in enhancing security protocols. Our commitment to security is unwavering. We must reinforce our dedication to producing secure and reliable software. Each member of our team plays an integral role in maintaining a robust supply chain security posture. It's not just a task for one department, it's a collective responsibility. For those looking to explore further, we have references that delve deeper into these topics. The SLSA framework documentation available in the official channels, insightful articles on Google's open source blog concerning SLSA and supply chain security, initiatives outlined by Linux Foundation projects, and resources provided by the SigStore project at sigstore.dev. These resources can offer more in-depth knowledge and insights into maintaining and improving the security of software supply chains.